Scientists have been trying for years to unite all of these laws of physics into one single theoretical explanation that would eventually become the fundamental source of the universe. But wait. What exactly are we trying to unify? Let's rewind to the four fundamental forces of the universe. We have gravity, electromagnetic force, strong nuclear force, and weak nuclear force. Bunch these together, you have quantum mechanics and you have Einstein's general relativity. See these? They don't get along. And scientists have been spending great efforts to try to let these things work into one origin. Einstein's general relativity deals with the fabric of the space-time continuum. It can be warped around, and it can result in gravity. You also know that space and time here are malleable by the constant of light, which means you could see different perspectives in different spaces or time, and generally, each perspective would be correct. Quantum mechanics, on the other hand, deals with a world where everything is built up on tiny quanta. Instead of a smooth fabric, you have a chunky world filled with probabilities and certain quantized ranges. An electron, for instance. We only get to know the probability of where an electron is in a specific space in a specific time. If we were to put these laws on each other's shoes, all mathematical equations break down. Gravity and relativity can't be explained on a quantum scale, and if quantum physics were to explain the cosmos, gravity won't exist. But one candidate for solution may be the key to solving the universe. For instance, if I would take this chunk of matter and magnify it, conventionally I would stop at elementary particles. But the string theory suggests that what if these are actually made of string-like filaments, vibrating at different energies. So what exactly can these strings do? Well, think of a guitar. Like the guitar, this string could vibrate in different energies and frequencies that produce the elementary particles. One could vibrate as a spark, one could vibrate as a photon, and one could vibrate as graviton, the theoretical force particle of gravity. Okay, perfect. Quantum gravity with other forces. Why is it still a theory? See, by calculations, scientists have concluded that for this to happen, we would have to have higher dimensions. Not 3D, not 4D, 10 dimensions. Now where would this be? See, dimensions aren't always as big as how we see things in our world. Some dimensions can be very small that it's impossible for us to see. If this is the 3D world, imagine this dimension to have thickness and depth. String theory suggests that within these 3 dimensions, there are 6 tiny spatial dimensions to which these so-called strings move around. A 6-dimensional figure can be represented by a Cabiau manifold. If relativity works with a one flat fabric, strings warp around different fabrics of space-time. With the smallest of precisions, it seems impossible to detect these types of dimensions. But scientists have continuously experimented ways such as the particle accelerator. It's a tiny whole world ahead of us that could finally answer the battle of the universe.